Bismillahirrahmanirrahim, dear students. Welcome to the Electrical Engineering channel. In this lecture, I will summarize all the equations which we have discussed in electromagnetic course regarding the electric and magnetic fields and the uh, combination or the summary of those laws and theorems were actually collected and combined, and collectively those set of equations were named as Maxwell's equations later. So Maxwell's equations for steady fields or the fields which are not time varying are written in front of you. So there are two forms of Maxwell's equations. First form is called point form, second form is called integral form. The first Maxwell's equations is a divergence of D or del dot D is equal to the volume charge density rho V, and this is also called point form of Gauss's law. And the integral form of the same expression is written over here, and that is d dot ds closed surface integral is equal to charge. This is called integral form of Gauss's law. So this is the first Maxwell's equation. Secondly, curl of electric field intensity is equal to 0, or del cross E is equal to 0, and the integral form of this expression is E dot dl closed line integral is equal to 0. So this is the second Maxwell's equation. The third Maxwell's equation is actually the Ampere's law, and the point form of Ampere's law is curl of magnetic field intensity is equal to the volume current density, or del cross H is equal to J, and its integral form is written over here, H dot dl closed line integral is equal to current, and this is the integral form of Ampere's circuital law. The fourth Maxwell's equation is del dot B is equal to 0, or divergence of B is equal to 0, and its integral counterpart is B dot ds closed surface integral is equal to 0. So the first equation is point form of Gauss's law, and here the first equation is integral form of Gauss's law. Similarly, the third equation is point form of Ampere's law, and here the third theorem is integral form of Ampere's law. And the second Maxwell's equation, del cross E is equal to 0, is Ampere's law in point form for electric field, and here the second equation, E dot dl closed line integral equal to 0, is actually the Ampere's law in integral form for electric field. And the fourth Maxwell's equation is Gauss's law in point form for magnetic field, and here the fourth equation, B dot ds equal to 0, is Gauss's law in integral form for magnetic field. So these are all the four Maxwell's equations. And one thing which we can deduce from these equations is that the electric field or electric flux lines always diverge from the source. So their divergence is a non-zero quantity. So divergence actually tells us whether the field is diverging from the source or not. And we know that if we have a point charge over here, electric field lines and electric flux lines will be diverging from the source. So the divergence of electric field and electric flux is a non-zero quantity, because physically these lines are diverging from the source. So their divergence will be a non-zero quantity. And we know that del dot D is equal to rho V, and del dot E is equal to rho V over epsilon, because D is equal to epsilon E. And the curl of these vector quantities will be equal to 0, because curl actually tells us about the circular orientation of the vector field. Okay, so if the vector field is actually circular in nature, then the curl of that vector field will be a non-zero quantity. Since these field lines are not circular in nature, so the curl of these vector quantities E and D will be equal to 0, and that's why del cross E and del cross D are equal to 0, which we saw in Maxwell's equations. Now we move towards the magnetic field lines, and we know that magnetic field lines are circular in nature, so their divergence will be equal to 0, right? So del dot B and also del dot H, they are equal to 0, but their curl will be non-zero because they are circular in nature, and we know that del cross H is equal to J, and since B is equal to mu H, so del cross H is equal to J and del cross B is equal to mu J. So this is the summary of Maxwell's equations and the short description of the point form of Maxwell's equations, and I hope you have understood the basic concept of these Maxwell's equations. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.